try to figure something out on your own instead of holding the bike the whole way. This is Thursday. Whoa, there's an extra day in February this year, so we have, but only one more school day in February. February 27th, 2020. Quadrilaterals. Let's see how you did.
I did great.
Not too bad yesterday with triangles. Ready, Bella.
Me and Jordan and Noel and Isaac are helping with the speech meet tomorrow.
Okay,
We might not
thank
be
you.
here,
All right, yep.
Yeah.
All right, here we go. What do we call, raise your hand, be recognized, what do we call a quadrilateral if both pairs of opposite sides are parallel? Hint, both pairs of opposite sides are, keyword, parallel. It's got four sides and both top and bottom, left and right are parallel. Jade. Parallelogram. Number 2, raise your hand, be recognized. What do we call a quadrilateral if only one pair of opposite sides are parallel? So maybe it's the left and right, or the top and bottom, but not both. No.
Isn't that true?
No. A rectangle is a parallelogram because for it to be a rectangle, both pairs are parallel. There's a special fun little word for, if you draw it, only one pair, David. Ready? Let's say top and bottom are parallel, but left and right are not. You know what that's called. What's that called?
A trapezoid.
Trapezoid is the answer to number 2. Everybody got that? Trapezoid. Number 3. A parallelogram with 4 right angles. Casey. Not necessarily, because a square is a parallelogram with 4 right angles, but you would need more information. A square would be 4 right angles and all sides are the same. Brett. It's a rectangle. Now, Casey, a square is a rectangle, so you can say technically you're right, but they want to know, they just gave you that information, so you can't technically say it's a square. Does that make sense?
Yeah.
You can definitely say it's a rectangle, but you're not sure it's a square. Has everybody got that? Okay, number 4. What is that thing? David.
You just said trapezoid.
Trapezoid. Number 4, the top and bottom are parallel, the left and right are not. Casey, what is number 5?
No, wait, sorry. 5 is a rectangle.
That's a rectangle, right? Now, you could say it's a parallelogram too, correct? But most precisely, it's a rectangle. Number 6, Spencer. All right, it's a parallelogram. Most precisely, it's a rhombus. Why? Because it's a parallelogram and all the sides are the same length. Wait, isn't that what a square is? What's the difference between a rhombus and a square, if there is any? Or how about if I ask you this? Is a square a rhombus?
Yeah.
Whoa, Kira. I'm not doing this to be funny. This is, you have to think. Ready?
Yes.
Is a square a rhombus?
Yes.
Let Kira answer. Is a rhombus a square? Could be, right? Yes. Listen, Kira, the definition of a rhombus is it has to be a parallelogram, so both top and bottom and the sides have to be parallel. And for it to be a rhombus, all the sides have to be the same length. So, Kira, this square, is a rhombus. But a rhombus doesn't have to make right angles.
But you said it's a rhombus square.
No, listen. Is a square a rhombus?
Yeah.
But a rhombus could be a square. Because that's a rhombus. It's a parallelogram and all the sides are the same. It could. The definition of a rhombus is a parallelogram and all the sides are the same. Both of these are rhombuses. I wonder if it's rhombi. Both of these are rhombuses, Kira, but only one's a square. So a square could be a rhombus, or a square is a rhombus, but a rhombus could be a square, but it doesn't have to. It's like I'm trying, Kira, to cause a little, listen to this phrase, ready? Cognitive dissonance. I'm trying to cause a little bit of, not confusion, but make you think a little bit to think through this, because you need to know. All right, number 7. If your angles in a particular quadrilateral are 85, 74, and 110, what's left? What does the fourth angle have to be, Micah? 91, because all quadrilaterals have how many degrees, Isaac? Turn the page. Number 8. I'm not that interested if you got these measurements precisely. Hopefully, wait, you didn't read? It says measure them. All right. So if you're close, I'll take it. Here's what the book has. The book did it in centimeters, by the way. So I'm not gonna quibble about it. That's why if we did it in inches, we're not gonna take that much time. But one thing we know is number 8, the sides are not the same. Okay? So how do we classify that thing? Raise your hand. Kira. No, the reason it's not a rectangle, Kira, is because a rectangle has to have 4 right angles. Parallelogram. Number 9. If you measured them, whether you did it in centimeters or inches, you should have figured something out about the sides of number 9. They were all the same. Now, it looks kind of like that. So what do we call that? Rhombus. It's not a square or a rectangle because it doesn't have 4 right angles. Number 10. Once again, when you measured the sides, you should have found that they were all the same. Okay, turn around.
She threw it at me.
David, turn around. Okay, who can give me 4 names for number 10 if I've already established for you that it's a quadrilateral? It's a simple closed figure. It's a polygon. It's a quadrilateral. What other 4 names could we give it? Starting with, listen to these words, starting with the most general to the most specific. The most general term, are you listening, Noel? For number 10 is that it's a simple closed figure. The next most general term is it's a polygon. It's made of sides. The next term would be it's a quadrilateral because it's got 4 sides. The next term would be, Bella, it's a parallelogram because opposite sides are parallel. The next more precise term would be, no, something, a rhombus. Before it's a rectangle, it's a rhombus because it's a parallelogram, right? And then it's a particular type of parallelogram. It's got 4 right angles at least, and that's what makes the rhombus a rectangle. And then, most precisely, what is it? A square. So the most precise answer to number 10 is a square, but it's also a parallelogram, rhombus, and rectangle. Did you catch all that, Kira?
Yeah.
Number 11. If you know those 3 sides, you can figure out the 4th by subtracting from 360. Micah, our resident expert on figuring out the fourth angle. Go ahead.
111?
Yep. No. Yes.
109.
109. Number 12. These are all the same. No matter what the quadrilateral. It's 360 degrees total. Dina? 105. Number 13. What's left? Jaden? 65. Okay. Number 14. This was the most challenging. You have a quadrilateral, but then they gave you an extra challenge there. They put an angle outside the quadrilateral. So the first thing you had to do was find the value of x. You had to add up 180 and 40. 220, what's left? For x.
X is 140.
Everybody following this? What was left for x out of 360 was 140. Jordan knows, based on her previous knowledge, if x is 140, y has to be, you're not Jordan, 40. Why? Raise your hand and tell me why. If you found out that x was 140, based on your knowledge now that you gained this week, you know that y had to be 40 degrees. Tell us why, Spencer.
Because X and Y have to add up to 180.
Because they're forming a
Angle.
180.
Straight line.
They're forming a line. In that case, it's a ray coming out of the bottom of that quadrilateral. Not everybody's here. You're all here physically. Not everybody's here mentally. Let's do that again. Number 14 is just like 11, 12, and 13 at first. How many degrees in every quadrilateral, David? Okay, so you add up those three that are given and subtract it from, so what's left? 140. Okay, now David, how many degrees in a straight line?
180.
So that line coming out of there, you already have 140. What's left to make 180? 40. No?
Yeah.
Okay. Number 15. More challenging. What do you know about the two angles on the right? Zacchaeus, you don't even have your book open. What do you know about the two angles on the right, Seth? They're 90. So you got two angles that are 90. Oh boy. How are you supposed to figure out the x and the y? If you're subtracting from 360, don't you have to know three of them? Figure out the fourth one? I got a strategy, says Rachel. I can figure out what x is based on my knowledge of how many degrees, again, are in a line or a ray. How many degrees are in a straight line? And if outside that parallelogram it's 115, what does x have to be? 65. And that solves our problem. Now we know x is 65, so 90 plus 65 is 245. What's left? 115. Did you follow all that? Some people look like they got notes for some other class out. Be here now. That's for this? Okay. Do I need to do 15 again?
Yeah.
Okay. How did I find out what x was? How many degrees in a straight line, Elise? In a straight line. 180. Noah, what's the angle outside the quadrilateral, number 15?
150.
What's left? How do I figure that out? Because it's making a straight line, isn't it?
Yeah.
Okay, so what's 180 minus 115? 65. Trust me?
Yeah.
Okay, now Noah, look at the quadrilateral. If I know that I have 90 and 90 on the right, and x is 65, what's left? All the quadrilateral angles have to add up to 360. So 90 plus the 65, 245, 360 minus 245. You sure?
Yeah.
Number 16, last one you had to do. Whoa. Who's confident? Who's supremely confident they got this one right? They have the odd numbers in the back of the book, right?
Yeah.
Okay. Who's only one person is really confident they got this right? Let's see, Spence. Ready? What's x, first of all, Spencer?
I got X was 72.
Why?
Because 54 is 108.
And how many degrees in a triangle? Everybody follow what he did? If there's always 180 degrees in any triangle, Spencer said 54 and 54 is 108. What's left? Jonathan agrees, 72. So X has to be 72. Now, how's that going to help us figuring out what Y is? Stay with me here. Keep your eyes on number 16. If X is 72, what's the angle right next to it have to be? Hello? Yeah. Listen. You see where X is? Look just to the right of X. What does that angle have to be that's in that parallelogram over there, or that quadrilateral over there? It has to be 72, based on what knowledge? Let's go to this guy, because we were picking on yesterday with this answer. Why does that angle have to be 72? It's right next to X, right across from it. Two intersecting lines. They form what kind of angles? Vertical. So now you know you have 110, 72, 105. Add those all up. Find out what's next. Okay, you're confused because you're more concerned about, do you like her, the pencil box, or the color? Which one?
What?
You mean what? Turn around. Okay, look. Shh. Follow this. Ready, Rachel?
Yeah.
Look at X in number 16. Do you see why the angle right next to it has to be 72 if X is 72? Because they're vertical. What do you mean no? Anytime you have intersecting lines, whatever this is, let's say this is 55, that has to be 55. Because they're vertical angles, right, Casey? Okay, so we've established that the angle, if you just look at the quadrilateral, Noah, one of the angles you're missing has to be 72 because X is 72. They also gave you 105 and 110. 105 plus 110 plus 72. Subtract that from 360, and Spencer says 73 degrees.
I don't understand.
Okay, let's go down to number 18. Tell whether the statement is always, sometimes, or never true. Jordan, a rhombus is a parallelogram. Your choices are, that's always true, that's sometimes true, or that's never true. Always true. A rhombus is always going to be a parallelogram first, going from general to specific. The more general term is parallelogram. Number 19. LP. A rectangle is also a square. Always, sometimes, or never. No. A rectangle is also a square. Go ahead. No. Yes. Sometimes. Listen. Back to 5th grade. A square is a rectangle, but a rectangle is not necessarily a square. A rectangle can be a square. This is a rectangle. Why? It's a parallelogram that creates 4 right angles. That's all a rectangle is. It's also a square. Not all rectangles are squares, obviously. But all squares are rectangles. So sometimes a rectangle will be a square. Number 20. A square is also a parallelogram. Jaden. Always. Has to be a parallelogram first. Number 21. A triangle is also a quadrilateral. Brett. Hopefully you said never. A triangle being a quadrilateral. Tri means 3. Quad means 4-sided. Number 22. A quadrilateral is also a rectangle. Always, sometimes, or never. Dina. No. Not all quadrilaterals are rectangles.
Oh, well, yeah, sometimes.
This isn't a rectangle.
Yeah, I know.
Sometimes.
I thought,
Raise your hand if you have any questions about 18 through 22 only. Listen, those questions are asked of you for a reason, Micah. You have to start thinking. We are out of elementary. We're not just, math isn't just computation. You have to think. All right. You're doing 23 and 24. Go. Not homework. We're going right now.
I have a question.
Yeah.
16.
Yes, what?
I don't understand.
David, I explained it twice. You were too busy playing with purple pencil boxes for me to keep explaining it.
I don't understand why X purple, why says
You keep practicing, David. You should be starting on 23.
Why do I have the purple box?
Play.
Okay, first of all, what do we got in 23? What shape is that? Raise your hand. It's a trapezoid because top and bottom are parallel, left and right are not, Isaac. So what do we know about a trapezoid? It's got four sides, it's quadrilateral. How many total degrees on its interior angles? 360. Okay, what have they given us so far? 58 and 62 up top. They said this guy's 58 and this guy's 62. They all have to total how much, Lauren? All four angles have to add up to quadrilateral. 360. The other information they gave us about the other two angles is E is 24x plus 1 and H is 25x minus 6. What do I have to do with all four angles? I have to add them. So I got 58 plus 62 plus 24x plus 1. You're going to get me upset if you're going to keep saying you don't understand it. You're not even writing it down. Where's your pencil? Well, let's go.
Well, I am doing it in my head.
No. This angle is 24x plus 1. And the angle in the bottom right is 25x minus 6 plus 25x minus 6. All of that, Noel, has to equal how much? 360. So here we go again. This is a perfect time for this. I started the week taking you all the way back to units 1, 2, and 3 and reviewing that. And this is more of it because, listen, 7th and 8th graders, by now, this should be like multiplying. You should have this so down. Combine like terms. No variable, x term. X term. Constants, just regular numbers. I'm going to put the x terms together and get 49x. 58 plus 62 is 120. Plus 1 is 121. Minus 6. Positive 115. That all equals 360. I'll stop there.
That makes sense. Yeah, that.
58's the top left angle. 62's the top right angle. 24x plus 1 is what they said this is. 25x minus 6 is what they said that is. I know that if I add them all up, my total has to be 360. I combine the x terms, got 49. I combine the constants and got plus 115. How do I get rid of the plus 115? Subtract. Do the opposite of addition, subtract to both sides. So now I got 49x, God bless you, equaling 245. I like when they're so kind to make the answer come out neat. Not to the nearest hundredth or something. You already done, Jade? How do I get rid of the 49, Sid?
divide it.
Divide both by 49, and I get 5. Wait a minute. Are you saying that one of these angles is 5 degrees?
No.
No! If x is 5, how much is this bottom left angle? It's 24 times 5 plus 1. 121. The bottom right angle is 25 times 5 minus 6. Did anybody add those up? Please tell me we did it right.
Okay, yeah.
If you add all those up, what do you get? 360. This is number 23. What's so interesting? Hi! Come on in. Oh my. This is a special delivery from,
25x.
this is Cetrelia. Uh-oh. You like that? Can you read that? Yeah. All right, what am I doing? Oh, thank you very much. Tell her, God bless and thank you very much. I'll take care of it. Thank you. Everybody got it? 23?
Yes, I do.
24. You should be done with 24, right, Bella? Good luck drawing that.
It's kind of like a.
I want to see you draw that.
You started laughing. I only drew one line. There's nothing to laugh at. There's absolute nothing to laugh at.
Well, it's not my fault. When you found out that I could you're kind of wrong.
Draw that in.
I think it goes, I don't know. Do you want me to help you?
All right, close enough.
No.
Close enough.
It's more
All right, what do we know? Oh, my shnikes. They didn't give us any constants. They gave us all the angles in terms of x, but we are undeterred because we know that everything's got to add up to 360, and we know how to combine like terms, and we know how to get rid of all the things attached to the x by doing the opposite to both sides. So let's see if I do it as well as you did. 3x plus 13 plus x plus 1. Plus x plus 4x minus 14. Whoa. And all that's going to equal 360. X, 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 x. Positive 3, positive 1 is 4, positive 1 is 5, positive 4 is 9x. Positive 13, 14. Whoa. 14 minus 14? Cool. How cool is that, Lauren? That actually saves us a step.
Wait, how'd you get 9x? I got 8x.
3, 4, 5, 9. This angle's x. Don't forget him.
Is it 3x?
Oh, it's a 1x.
1x?
I don't know.
This one's 3x plus 13 up here.
Yeah.
And
X plus 1.
this one's x plus 1.
Yeah.
And this
Four,
must be
yep.
4x minus 14.
I didn't answer.
Okay. Never mind.
Got
I
it?
forgot about the answer.
Look. Crisp and clean.
40.
No caffeine.
That's right.
All right, if x is 40, if x is 40, this angle is 3 times 40, 120. So we got 133 there. This is 40. 40 plus 1. 4 times 40, 160 minus 14. Did anybody add those up? Please tell me it's 360.
I did it, but I know
It is.
360.
It's more of a diamond than a
It's not supposed to be a rectangle, dear. It's a quadrilateral.
No, but I said it, we'll just talk about diamond in the book. Because your corners are kind of crooked.
Everybody good? Moving on. Moving on. Miss Larisha. Do you know who Miss Larisha is? Were you here last
You
year?
need Mrs.
Well, how do you know who Miss Larisha is? You know Mrs. You don't know Miss. So Miss is Mrs.'s daughter, who is teaching in Germany. She was here for a couple of years.
Yeah, she was our fourth grade
She
teacher.
was your one?
Yeah.
She was here 3 years.
Yeah.
You were her first class.
Yeah, we were her. We were there too.
All right,
That's like his.
listen. Move. Whoa, we gotta get done here. You're gonna have more homework. Things get a little more complicated, Kira. Are you ready? Yes, you are. Page 390.
No, it's because.
We're ready for page 390.
Let's go.
390.
All right, listen. I'm going to take your attention to page 391 right in the middle, because that's what we really have to focus on. Everybody go there. Angle measures in any polygon. N minus 2 times 180. So let's start with the real simple thing. How many sides in a triangle?
3.
Okay. If there's 3 sides in your polygon, now we're going from triangles to quadrilaterals, and now we're opening it up to, I think I reviewed this yesterday, 5-sided figures, raise your hand, which are called pentagons. 6-sided figures, which are called hexagon. 7-sided figures, which are heptagons. 8-sided figures, which are octagons, nonagons, decagons. Okay, so we're opening it up now to different shapes. So here's the formula for all polygons. Ready? The number of sides minus 2. How many sides in a triangle? 3 minus 2. Have to put that in parentheses because that means you got to do that first. Times, come on. Stay focused and then get you started. 3 minus 2 times 180. What's 3 minus 2?
1.
What's 1 times 180? How many degrees in every triangle? You get it? Okay. What's this called? Quadrilateral? How many degrees in all quadrilaterals? Let's use the same idea. 4 sides minus 2 times 180. What's 4 minus 2? It's 2 times 180. Somebody out there figure out how many degrees are in every pentagon. Go ahead. Pentagon. Based on what I just did, you tell me how many degrees are in every pentagon.
What is it?
It's the formula. You know, formula like length times width equals area. This is what it is. You can figure out the degrees in any polygon, including this room, which is beyond the dodecagon. You know what a dodecagon is? A 12-sided figure. Because if you were to analyze this room, it's kind of a rectangle, but it's not. You'd have to count every side to figure out the perimeter of it, all those little sides that jut. So, but listen, we would be able to figure out the total degrees of angles in this room if we went through and counted. I did it one time. I can't remember if it's 14. I think it's more than 12. But anyway, how many degrees in every pentagon, Kiara?
4 or 5.
Yes, because, Jordan, how many sides in every pentagon? Always subtract 2. And then multiply by 3 times 180 is 540. How many degrees in every hexagon? Hexagon has 6 sides. Subtract 2. 4 times 180. 720.
Oh, yeah.
How many degrees in every heptagon? 900. You follow the pattern here. Okay, all you have to do for homework is 1 and 2 at the bottom of 391.
1 and 2.
Hold on. And then, yeah, that's it.
Thank you.
We did cover a lot the last week.
We did. Thank you, Mr. Franken. You're the best.
And you did fairly well figuring things out as I tried to let go of the bike for you.
I can't try.
Love demands that
I don't know what I like it.
you gotta go on your own.